And now, having that, we understood about the definition of the physics as the study of the fundamental laws of nature. And being that these laws of nature are expressed in terms of the mathematical expressions, so now the point of interest is what really constitutes to the mathematical expressions, or what are the components of the mathematical expressions. Now, these mathematical expressions consist with what we call the physical quantities. So, which means the mathematical expression that we're talking about consists with what we call the physical quantities. So, each and every a formula in physics must have to consist with what we call the physical quantities. So, what are the physical quantities? These are the quantities that can be measured. So these are the quantities that can be measured. That's said to be the physical quantities. And we have the quantities like, let's say, the mass. We can be able to measure the mass. That's part of the physical quantity. And we have, let's say, the speed. And we have acceleration. These are the part of the physical quantities. And we have the length. It can be that. We have the distance. Can be that. We have the speed, and we have a lot of examples of the physical quantities. We have the velocity, can be that, and we have the impulse, and we have the momentum, so it can be that. And also we have, let's say, a torque, so can be. So these are the part of the physical quantities. So these are the quantities that can be measured, and they are the ones that constitute the they are the ones that constitute the mathematical expression of the law of the nature. So now, these physical quantities are classified into two classes. We have what you call the fundamental physical quantities. So we have what you call the fundamental physical quantities. Now, these are the quantities that cannot be expressed in terms of the other. So the fundamental physical quantities cannot be expressed in terms of the other. We have the likes of, let's say, the mass. You cannot be able to express the mass in terms of that. In other words, there is no combination of any other physical quantity other than the mass itself. We have the length, it can be that, and we also have the time. We have the temperature, and we have the current as well. So these are what you call the fundamental physical quantities. And we also have what you call the derived physical quantities. Now, as the name itself suggests, derived means originated from. So the derived physical quantities, these are the quantities that are expressed in terms of the other. So they are expressed, or they are derived from the combination of two or more fundamental physical quantities, just by a multiplication or division. So that's about the derived physical quantities. The likes of speed, they are part of the derived physical quantities that consist with, let's say, the length as well as the time. So they consist with length, so it should be like this. So for example, a speed consists with the length as well as the time. So that can also be said to be the distance as well as the time. And let's say, for example, the force is also part of the derived physical quantity. So we have the force. That one consists with the acceleration as well as a mass. So that is part of the derived physical quantities. And we have a lot of examples of the derived physical quantities that you can be able to come across with. But keep that in mind. Try to look for more examples of the derived physical quantities that can be able to have to come across with. So keep that in mind. So that's how you have to understand about the physical quantities. And you can also be able to classify the physical quantities in terms of the vector as well as the scalar. So a vector quantity It should be a scalar quantity. This is a physical quantity that is only expressed with a magnitude only. We can have, let's say, the mass. So that is the part of the scalar physical quantity. And we have, let's say, the temperature. We have the speed. That is part of the example of the scalar physical quantity. So it should be that. And we have, let's say, the distance. So in the main of them you can be able to come across. Just have to look for or try to Google what are the examples of the scalar physical quantities. Now we have what we call the vector physical quantities. Now these are the quantities that are expressed in terms of, let's say, the distance as well as the magnitude. And for example, we have the acceleration, that is also part of the vector physical quantity. And we have the displacement, is also part of that one. And we have, let's say, the velocity, and we have a torque, we have the momentum, we have the impulse. So these are the examples of the physical, actually the vector physical quantities that should be able to come across. But the such to have to understand about the physical quantities as one of the components that constitutes to the mathematical expression as far as the physics is concerned. So keep that in mind. So which means the entire physics will be dealing with these actually physical quantities in one point or the other. No formula will be expressed in physics without these actually physical quantities. So mind you, these actually physical quantities in derived physical quantities now are rated by multiplication or division. Otherwise, we cannot be able to have the combination of two or more physical quantities by addition or subtraction, because it is impossible to have, let's say, 2 seconds minus 50 kgs. This is impossible. We can only be able to have the combination of the two or more different physical quantities by multiplication or division. No wonder we can have, let's say, the meters per second. This is acceptable, but not meters per seconds. No, can't be that. So keep that in mind.